Okay, today's lesson is going to be on chapter 2.3 in the textbook, and we're talking about complementary and supplementary angles. And just know this, as I'm recording this, when you pull this up on YouTube, you're going to see all of this. Yes, I want you taking these notes in class. But you can, yes, you will see this, on YouTube. If I actually start writing on the board, you're not going to be able to see me on YouTube. You'll hear my voice, but you'll see it as I scroll down the screen. You'll see that happen. And anything that I write on here, you'll see me switching over so that I can write. You'll see everything that you see up here on the board is what you'll see on YouTube. Okay. So what we're talking about in chapter 2.3 are special pairs of angles, complementary angles and supplementary angles. All right. Now, first of all, what we've got to do is talk about what is meant by complementary and what is meant by supplementary. Many of you already have an idea about this. You see the definitions. Complementary angles are two angles whose sum is 90 degrees. Okay. Any two angles whose sum is 90. And I want to focus on this. Any two angles, not three, not four. Okay? Any two angles whose sum is 90 degrees. Supplementary angles are two angles whose sum is 180. And I want to stress the 180 and the number 2. Not three angles whose sum is 180, but 2. All right? You're going to see these recurring very often in studies of geometry. All right? And you'll see them again if you ever take trigonometry. You'll see especially the complementary angle pairs used a lot. Or now, so let's say you've got an angle of 40 degrees, and I were to ask you to find the complement of a 40-degree angle. What would I do? It would be a 50-degree angle, and how would I find that? I would take the 40 right here, and I would subtract it from the 90. Right? Complementary angles add up to 90. So if I subtract what is known, the 40-degree angle here, from the 90, that's going to give you your other angle. That should be pretty common sense, right? And you can take the two angles, 40 plus 50 equals to 90, just to check yourself. Okay? But again, it's two angles, not three. 40, 40, and 10. Do not try to classify those as complementary because there's three angles there, not two. All right. So this little sign that you're seeing right here, the equal sign with the slash through the center of it as an angle, that's the not equal to symbol. Now to find the supplement, what we refer to as the supplement of an angle, is we're talking about the same idea. If we're again talking about a 40-degree angle, all right, then you would find it in the same way you would find the complement, but instead of subtracting from 90, you subtract the 40 from 180 to find the other angle. So 180 minus 40 is 140. Now, another angle set that we need to, angle pair that we need to become familiar with are these angles that are known as adjacent angles. Adjacent angles. Adjacent angles are angles, two angles, that are, they're said to be adjacent if they share a common vertex, a common side, and no overlapping interior points. Basically, that means you can't have one angle contained within another and then be considered adjacent. I mean, you can have that, but they're not by definition called adjacent angles. Okay? So, I drew this diagram here of the big angle A, B, C. Okay? Now, ray BD extends from the vertex B. What I have done here is created an angle. Sometimes remember, angles can be named by numbers, and when that's the case, you'll see a number written in between the two rays indicating that, for example, angle ABD here, I can call angle 1. Or instead of referring to this angle as angle DBC, I can refer to it as angle 2. A little bit easier. Sometimes you'll see that just for convenience sake in the textbook, they'll use the names of angles as numbers instead of letters. Because if I were to use a letter designation for either one of these two angles, how many letters would I have to use? I'd have to use 3. I couldn't just use 1, could I? I could not refer to any angle here as angle B, because there are actually 3 angles pictured here. There's angle ABD, DBC, and then ABC. Right? You've got 3 angles pictured here. So you would, if you were going to use letters, if I specifically wanted to refer to angle 1, name it by letters, I'd have to use a 3-letter designation, ABD. So why not use the number instead? It's easier. If it's given to you, use it. I did go ahead and use a 3-letter designation here just to indicate here specifically angle ABD and DBC. Are these 2 angles here by definition adjacent? Well, let's look at them. ABD is here, and DBC is where you see the number 2. All right? Now, do they share a common vertex? Let's see. Do they match? Does everything agree with the definition here? Do they share a common vertex? The answer is yes. B is the vertex to both angles. Do they have a common side? The answer is yes, because they both share ray BD. And do they have any overlapping interior points? No, because all the points in between the rays BD and BC are unique to that angle. You don't find these points contained over here in angle 1 or angle ABD. Now, what about this? ABD, where we have right here, you see where ABD is, and then ABC, the big angle. Would they be referred to as adjacent? Well, they both share a common vertex, B. ABD and ABC share a common side inside AB, right? They both have that side, but they have overlapping interior points. Angle ABD is contained within ABC. So because of that, those 2 angles are not considered adjacent. Got it? So be careful with that. Some other definitions that I want you to be familiar with. Theorem. A statement accepted as true without, or a statement accepted as true with proof. A postulate is a statement accepted as true without proof. All right? So write those definitions down, and then I want you to take a moment. These 2 theorems right here, 2.1 and theorem 2.2. You will find those over on page 69. All right? These are over on page 69. I want you to write those down. Okay? I'm going to pause this. Okay, so the congruent complements theorem. It says if you have 2 angles that are complementary to the same angle, they're congruent to each other. 2 angles complementary to the same angle, they're congruent to each other. And here's an example of this. If you have, I drew these angles here, 1, 2, and an angle 3 here. Let's suppose that angle 1 plus the angle 2, if I knew what their measures were, that they equal to 90 degrees. And let's also further suppose that angle 3 plus the measure of angle 2 also equal to 90 degrees. Well, then I can surmise from that that angle 1 must be equal to the measure of angle 3. Okay? If 1 plus 2 is 90, 3 plus 2 is 90, then angle 1 and angle 3 must equal to the same. So these 2 angles must have the same measure, because both of them, when combined with angle 2, creates 90 degrees. That's the idea behind the congruent complements theorem. And it's like the same way with the congruent supplements theorem. You're just talking about angles whose sum is 180 instead of 90. Okay? Now, I want you to keep in mind here, and I don't want you to get bored with this, but keep up with these little finer points because it will help you in solving some of these problems that you have for homework. Given that the measure of angle 1 is equal to the measure of angle 3, okay? One of the things we can state about the measure of angle 1, if I come back up here to this equation here, if I solve for the measure of angle 1, now watch this. If I solve for the measure of angle 1 and I subtract the measure of angle 2, from both sides. What happens is I get this statement right here. Okay? So if you're given the measure of a particular angle, let's say angle 2, and you're told to find the complements to that angle, we're looking for a measure of, let's say, some angle 1, subtract it from 90. Measure of angle 3, we would do the same type of a thing there, okay? So you'll have to do some of that. So to solve for the measure of angle 3, what would I do here? Measure of angle 2, subtract it from both sides. And this also further illustrates why it is angle 1 and angle 3 are the same. You see they're equal to the same thing? If the measure of angle 1 is equal to 90 minus the measure of angle 2, and then the measure of angle 3 is equal to 90 minus the measure of the angle 2, I can use my substitution property of equality to therefore say that the measure of angle 1 is equal to the measure of angle 3. And if the angles have equal measure, what can we further say about them? They are congruent.
What is measure 2?
We don't have a specific measure for that because I don't know the exact measure of angle. I don't know the angle 1 or angle 2. This is just a general format. Okay, this is not a specific problem. This is just giving you a general outlay of some fundamentals that you need to be able to do when you get the specifics for, let's say, what a measure of angle 1 would be or angle 2, how to find the other one. Okay? Okay. Okay, I posted up here your assignment for tonight for this section, pages 70 to 71, 1 through 27, deals with these issues, these concepts. This is what I'm considering your Thursday work. Your Friday work, down here, page 49. Thought it would be a good idea to review some algebra. Okay? I do want to review a little more algebra here in just a moment in the class, but this is your Thursday and your Friday work right here. A little word of caution. Something didn't happen today, did it? Something might happen Monday. What might I be talking about? An algebra little pop quiz? Well, think of it as a cue word. It's not going to be as heavy as test, but a little bit of a pop quiz for some of the algebra stuff we did yesterday in solving equations.